Hey guys, my progress has been a little bit slower on this Dumont than I would like, partly because I found out that there are more issues with power resistors. So if you recall, there was a 25K 5 water down in here and I couldn't find a perfect replacement for it on hand, so I ordered some up along with a bunch of other parts, and I thought that would be all I would need to finish this project off. However, I was really hoping that these guys would still be good, and it turns out at least this one is not. This is what they call a canned ohm resistor. I think it's because it's a resistor in a metal can. It's mounted to the chassis to help dissipate the heat. These are often problematic, and this one is no exception. Turns out that even though there are 5 lugs along the length of this, there's actually 2 resistive elements in here. It's between these two sections, between these 3 lugs. So one resistive element here and one here. These other lugs where we've got some big external resistors soldered across are just mounting lugs. There's no internal elements there. Well, turns out after I unsoldered all these wires and double checked it, this section, well, I can't exactly say it's open. It measures about 300,000 ohms. 300 kilo ohms, in other words, whereas it should be 2400, or sorry, 2140. It's that guy. Our 282B. Our 282A measures about 1500, so it's pretty much on value. What's inside here are wire-wound power resistors, and I suspect this one is either corroded or it's partially burned through to be so much higher in value than it's supposed to be. And I figure if this one's bad, this one may not be far behind, so I should really replace both of them. Now it's tempting to just tack in new resistors across these lugs like they did here. However, there is still some continuity inside here, and you never know, over time that connection may reconnect, like the set gets jostled or something, and then the resistance will be much lower than it's supposed to be, so it's generally not a good idea. What I've seen some guys do is, if you're able to somehow get inside this can, like with a Dremel cutoff wheel, or maybe if you can unmount the whole thing and make sure that that is permanently disconnected inside, these do make great mounting lugs for the new resistors. I don't know that I can do that. This is riveted on, and I don't know. I don't really want to try taking a Dremel cutoff wheel and getting in here. I don't want to nick this or this guy over here. It could be tough to get in there, so I got to figure out some way to mount some new resistors. They're kind of oddball values, but I figure 2200, which is a standard value, is close enough to 2140, and 1500 should be plenty close enough to 1480. Why they chose such oddball values, I don't know. It's probably just Dumont being Dumont, because they could. Likewise, why they put two 3.3K in parallel, when I would think that something like a 1.8K would have been close enough. Alright, and I have not checked this guy yet either. Oh, and for the wattage, Dumont didn't specify, but one of my buddies on Video Karma has a copy of the SAMS, which has somewhat different info, and they say 10 watts. See, what riders would typically do is work with the manufacturer and just reproduce the factory service info. So this rider stuff I printed out is exactly the same as the Dumont service manual that I have, whereas SAMS would just go buy a set and then reverse engineer it. So whenever possible, it's nice to have both, so you can kind of cross-reference between the two. Which brings me to another odd situation. So with the new parts I was able to finish recapping this whole area, replace resistors that were off. Then I got to this guy, which once I cleared the gunk off, looked pretty clear to be yellow, purple, black, or yellow, violet, black, which would be 47 ohms. Schematic says 100 ohms. However, again, the SAMS does show 47 ohms, with a service note saying that some models use 100 ohms. When I measure that, it actually does measure close to 100 ohms. However, Dumont, I don't think, would have hand-selected 47 ohm resistors that failed quality control and really did measure much higher than this marked value. I think this really should be 47 ohms, and it's just drifted way off value over time. So I'm going to replace that with a new 47 ohm. So I'm going to replace that guy, replace these, test, and possibly replace that guy. And then I got a few more caps up in here. One there, one there, one there, one over here. And then flip this thing down and get inside that high voltage box to replace the caps inside there. Once again, I went through all my power resistors and I just do not have what I need. So I'm going to have to place another order. But in the meantime, I found something that's close enough so I can continue on with this project. I'm starting to question whether it's even worth hanging on to all those old power resistors rather than just ordering them as I need them, because it seems like I never have what I need. So what I dug up was a 2K 13 watt resistor. This one's brand new that I bought for another project. But in the meantime, I'll use it in here. It should be a 2140, 2000, I figure it's close enough. And for the other element, I'm going to use the original one that's left inside here. Eventually, I definitely want to completely disconnect these three terminals and put two new power resistors down in here. Alright, so I'm going to move on and finish off the recap on the bottom. Just a few caps left over here. Then I want to flip this thing down and take a look inside the high voltage cage and replace those three high voltage caps. I received some advice telling me that it should be possible to remove the yoke and focus coil while leaving the CRT mounted in the cabinet, so I'm taking a closer look at it. So for sure there's a big metal collar with padding that goes around the front of the CRT. And then there's this bracket that hangs down and supports it in the rear. Here's the focus electromagnet. The yoke is going to be down somewhere in here. And here's how it connects to the chassis. And what I wasn't sure was, how do you take the yoke and the focus coil off while leaving it supported? If you take this whole thing off, the CRT will just fall out. Well, for sure, there are some screws around here that would separate this metal disc from this bracket, and it looks like there are a couple rubber pads on here that maybe stay behind. Yeah, okay, because this metal L bracket comes down from here, and that's on the inside towards the CRT, whereas this plate would come off. So the question is, what's the easiest way to do this? Do I really have to take all these nuts off? I can see there's speed nuts clipped on the other side. These black metal things that clip on and are threaded internally. I might be able to just loosen them up and they slide off. I suppose maybe I should take a look at the service info. Okay, and I was also told that there's a thumb screw here, which actually is quite loose already. So that would be on the yoke, which allows you to slide it left and right to a correct picture center. But you can see there's also a slot here. So if I loosen that up a little more, it doesn't want to slide. I know somebody on video camera had a problem where the yoke was pretty well fused to the bell. Oh, it's going, just not easily. Alright, so now that'll slide back. But we got all this stuff too. So I'm going to peruse the service info. Sometimes they give you tips on disassembly. If not, well, let's see. Yeah, I guess 1, 2, 3. I think just 3 1/4-inch nuts I gotta remove. That should all come out. Well, I got it off without too much trouble. Turns out there was nothing in the service info about how to actually do this. So in the end, I just took out those 3 bolts, and that's all it took. You do not need to loosen that thumb screw at all, actually. So I ended up just tightening it back down. It did stick a bit on the neck though when I first started to slide out until it got about here, then it came off very easily. And now I know why. It's because this is a rebuild. Weld right there. So I cut off the old neck and put a new one on and welded the glass back together. And there's a bit of a bump here. So it's not the neatest job I've ever seen. Hopefully it won't cause any problems. Alright, so be very careful to leave this alone. Don't want to bump into that neck and crack anything. Now with this, I can power this up on the workbench with the test CRT. Except that if I do leave the focus coil powered up, I may not get an image on the CRT because the test CRTs are auto-focusing, in other words electrostatic focus, and they do not require an electromagnet, and the electromagnet will actually cause it to defocus and maybe lose the image entirely. So I may have to do something to bypass it or just remove it. I really don't want to remove it though, 'cause see it's got these spring-loaded screws. That's how you center the picture, and that's why I didn't want to mess with this thing any more than I absolutely had to. But in the end, if it makes servicing the set easier, I guess I will. It just means when I put it back together, I got to go through the process of tweaking everything. Something else I did notice in the service notes was about the ion trap magnet. I noticed it was very close to the base. In fact, it was slightly on the base, like right about here. And they expressly mentioned that in the service notes, that if you replace the CRT, you may have to put the ion trap magnet all the way to what's touching the base to get the picture looking right. Apparently that's because the sets originally came with a 17 AP4 CRT, whereas the latter versions were used 17 BP4s, and this magnet is actually too strong for a BP4. So if you put it in the normal place, like around here, it pushes the electrons, or doesn't align them right onto the screen. So that's something some of you may not be aware of, is that all these magnets are not created equal. There are different strengths, and different sets, different CRTs rather, require different strength magnets. Which reminds me of this gizmo I recently came across in a junk box, which is a variable Gauss adjustable ion trap. What I mean is you can change the strength of the magnet. So here's what was in that box. Apparently by adjusting this shaft here, you can change the strength of the magnetic field. So this might be an interesting thing to try out on this set. So instead of having it so close to the base, you could put it maybe around here and use this in conjunction with moving it around on the neck to get the best picture. However, this is the only one I've got, so I can't leave it in this set, but I just thought it might be an interesting little experiment. In a recent video, I mentioned that I was having a little trouble finding flush cutters locally. Well, I did end up finding some. I got a couple cheapos from Menards for $2 each that actually work quite well, and I ordered up some name brand ones from Mouser Electronics, and I just tried using them and was very disappointed to find out that the cutting surfaces do not line up. These are nearly useless. So, very disappointed, because these cost about $5.50 and the $2 ones work much better. I suppose I could complain or return them, but for the amount I paid, I don't think it's really worthwhile. Alright, so moving on to the high voltage box. I discovered that you can actually take this lid off quite easily. Makes it easier to get inside there. But not easy enough, because I want to get down in there. There's a cap way down in there. So, I have to dismantle this high voltage box somehow. Let's see, looks like we got a bunch of 1/4" nuts. 2 there, 1 there, 2 on the other side here. One more on the other side. And I think this whole box will come out. And I may replace this high voltage lead. Somebody cut it and spliced one on. Now, other owners of this set said that originally, at least I think they said this, that there was some kind of a quick disconnect here. Originally I thought that maybe the original 16AP4 CRT had a different kind of high voltage connector. But no, I don't think that's the case. And I'm also just noticing that this is really pretty crummy. Some kind of coating on this, and it's like screwed up the rubber. The rubber's just disintegrating on its own, so I think I'm just going to replace this whole darn thing. I've got new high voltage wire, some good stuff with a good new suction cup on the end. So let's replace this whole thing all the way down into that hole. This electrical tape, no. When you've got upwards of 20,000 volts on this wire, the electrical tape is nowhere near sufficient. It's probably only good for 500 volts or something for a single thickness of this. And unless you wrap like half a roll around this, I wouldn't trust it. And even then, that's just a really half-assed solution. I can tell that there's a thick solder joint right under here. There's probably like 1 or 2 layers of tape. So if this came near the chassis, it would just arc right through this tape. Well, it's even worse than I realized. There's 2 splices, so we've got this suction cup length of wire, splice, 2-inch length of wire, another splice, and then what I presume was the original wire. So, I presume something happened to the original wire. Somebody had this handy, wasn't quite long enough, they had to put another extension on here, so that's really gotta go. And this isn't even high voltage wire, this is just a piece of line cord. Just regular old, like 18 gauge stranded line cord. Alright, so I think I can do a little better. So maybe something like this. Brand new, it's probably rated for 40,000 volts. Yeah, I think that's what it says, 40,000. Plenty. My problem is I'm not entirely sure this cup is going to work quite right. Should be something more like that, but this might work if I mush these in. Otherwise, I'm sure I've got some others lying around I can use. Just had to remove a bunch of sheet screws and the whole box just came right off. So I have easy access to the whole high voltage area now. Also couldn't help noticing that there was 1 screw missing, so some work may have been done down inside here in the past. We shall see. Looks like this cord's got some tape on it too, but it's the same color and it looks like the same wire, so might have just been an issue with some leaking. Although, well, no, this is all insulating material. I wonder why somebody did that. Maybe just to keep it from flopping around. No, because it fits pretty snug in there now. There's not that much voltage on this, it's just going to the plate on the horizontal output tube. Alright, so this set uses a voltage doubler. So there are 2 high voltage rectifier tubes, both 1x2s, one here and one over here. And that's why there are 3 high voltage caps. 2 for the doubler and 1 to provide a little extra filtering, I believe. I think the total output is something like 16,000 volts, so each doubler has about 8,000 on it. Let's see. No, well, I guess only 12,000 volts. It's a little less than I would have expected. They're showing 6.3 on the first tube and then 12 on the next because there's some losses involved, so. Huh. Wouldn't have thought 12,000 would be enough for a 17-inch CRT. Well, whatever. That's what they say. We'll find out when the set's up and running. So also got some high wattage resistors, or I gotta check. But they're all 470Ks, they're really just bleeders. One mica cap, I'll just assume that that's okay. 68 ohm resistors, probably there for current limiting. Yeah, it's in series with the horizontal output tube. And there should be a couple 2.2 ohm resistors hidden down below, which are current limiting for the rectifiers. I've seen those drift way out value in other sets. Yeah, I can see them. They're hiding down there in the sockets. Here's a better look underneath. There's the corona rings they put around the high voltage rectifier tubes to reduce the chance of any arcing or corona. This is 2.2 ohm resistors. This one looks pretty darn cruddy. In fact, it's falling apart. Chunks of it just broke off. I'll replace that. Good idea while you're down here to clean off all this dust. Eventually, if enough dust builds up, you can start getting some high voltage arcing. And all that dust builds up because it's attracted by the high voltage. His wires are actually white underneath all that. Alright, so this is what I'm going to be using for replacements. I think if I bend the leads out a bit, should have no problem spanning that gap. I think I know why that high voltage cover had been removed. All three of these caps have been replaced. Just notice that there are remains of old leads at both ends. See that the old lead was just wrapped a curly Q fashion around the new lead. Not exactly the neatest way to do it. So I just pulled that off. So it's just wrapped around there and then pushed on. There's really no reason for that either, because these are actually pretty easy to solder to, because these are like cups. And all you gotta do is plunge your soldering iron tip into them and the whole blob of solder melts, and I can get that old lead right out of there. And then you just plunge the new component lead into that same solder blob. That's all to prevent there from being any sharp points. Taking a little while to heat up because it's a big blob of solder. If you have any sharp points, the high voltage tends to collect on those points and want to arc over to other stuff. You can see the old lead starting to loosen up now. There goes the blob about to fall down. So, there we go. Get out of there. There's the old lead. So when I solder this, I think I will flip the chassis completely upside down. So when I put a new blob of solder in there, gravity won't pull it down. Not in this direction, not in this direction anyways. It'll just kind of go in this way, and that's alright. I figured out that if I put some coffee can strategic points, I could flip the chassis upside down without causing any problems. And I finished off the work in the high voltage area, at least on the bottom side. So here's a new high voltage cap, nice shiny smooth soldered blob there, and the two new 2.2 ohm filament resistors. So I'm going to flip it back over and show you something kind of interesting that I discovered. So we've got these three resistors connected in series, kind of hanging in space. You see those on the schematic here, the three 470Ks in series. So why would they put three resistors in series like that? Well, resistors actually have a voltage rating. If you exceed that, they can start breaking down and forming conduction paths bypassing the resistive material. So in other words, it will break down the resistance and more current will flow through them than should. And it turns out that the larger the wattage resistor, typically the more voltage they can take. So these are 2-watt resistors. There is not 2 watts of power being dissipated by these. It's just that 2-watt resistors can take more voltage than 1 watt or half watt. So, but not enough to bridge this whole circuit here, so they put 3 of them in series. Still not quite sure that's enough. Okay, it's not going to ground. I was going to say 3 of these in series is not enough to handle 6,000 volts, but it's between the plate cap here, which they show as 6.3, and the filament / cathode over here, which they show as 6.3. So it's probably a few hundreds of volts across these. Typical resistor, I think a half watt can handle like 250 or 300 volts, a 1 watt, maybe 350, and a 2 watt, like 400 or 450, maybe 500, something in that ballpark. And the reason they've got these same type of discs here so that there are no sharp points. So, what did I find that was kind of interesting aside from these resistors hanging here? Well, check this out. This is white high voltage wire like here, but in this area it's red, and then there's a notch in it. That's because I suspect something got too close to that wire, like one of these resistor leads, and must have formed an arc and burned through the outer white insulation, expose the inner red, and then actually burned a notch right into the insulation. And I think the other wire got a little bit affected too, so I am going to put some goo on that to help it out. I could put the super corona dope, but this stuff hardens kind of brittle, I think. As long as I don't flex the wires, it might be okay, but it might fall off too. Or I've got this stuff, high voltage putty. Will not shrink, harden, non-flammable, so you just kind of break off a chunk. It's like clay, and you mush it around the area. I'm not going to replace the wire. That's too much work. It loops all around the flyback and back around through here. So, I guess there are probably multiple failures in here. They replaced that anode lead. Looks like they replaced all 3 of these high voltage caps. Looks like more evidence that this one was replaced here too. This lead's just kind of, it's sticking out here, so they got a sharp point. That's not the way you should do it. They should have just plunged it right into the center of that donut. And this one looks a little sloppy over here too. And then, there was some kind of failure over here. Hopefully the flyback hasn't been damaged with all this going on. I'm finally done with this high voltage area. Got all the new high voltage caps in there, new high voltage wire. Got the solder cups filled up nice and smooth. Cleaned up all the excess gunk around here. Some of these wires were kind of fraying, so I cut the ends off, restripped the wires, and got them seated firmly now. The only thing I have left is the end of the lead. I was going to salvage the cup from this, which I thought was soldered on, but I think it might be crimped on, so it might be a little tough to get off, but I'll dig up something. But for now, that's going to be it for tonight. I will pick up in the next segment